Okay. So we're going to talk about fourth grade math, or is this fifth grade math?
This is fifth grade math.
Fifth grade math. Okay.
Although I will be doing it fourth grade soon.
Nice. So when you were getting ready for this, what cheek subjective are we looking at?
This is, oh gosh, I think it's 5.3B. It has to do, it's multiplication, multi-digit multiplication.
Multi-digit multiplication, okay.
Mm-hmm.
So what have you done in the past that the kids are kind of building on as far as
right.
prior knowledge?
Right, so they have, you're right, we've been exposed to this last year because it's in the fourth grade curriculum as well. And when we started talking about it, because this is chapter 2, so in the book, so we started talking about it, and we started off with just doing the properties of multiplication. So things like it doesn't matter which order the numbers go in multiplication. 6 times 9 is the same as 9 times 6.
Right.
Or things like the associative property, where if you have 3 factors that you're multiplying together, you can multiply 2 times 3 and then multiply by 6, or you can multiply 3 times 6 and then multiply by 2, and it gives you the same answer.
So that's prior knowledge you hope they come in with.
Yes, but we also we spent a day on it just reviewing them, and most of the kids are like, oh yeah, I remember that.
Okay,
they
that's
just
good.
needed refreshers and stuff like that. And then we moved to doing they call them special factors, where you have zeros in one of the factors, so things like 7 times 50, and they want a shortcut way that you can do it is multiply the non-zero digits first, and then you add the same number of zeros in the factors to the product.
That's a lot different than when I was in school.
Yeah, it
seems a lot easier.
Yeah,
more mental math kind of things.
Yes, a lot of mental math, which I don't think they have necessarily needed to do before.
Right.
Because there's a lot of times where, I try to get them to do mental math, and they can't. They're like, no, I have to write it down. Which I understand, because I'm a visual learner.
Right.
So I do a lot of things. Sometimes the kids will ask me questions. I'm like, I didn't understand what that was, but if you write it down, if you can show me a problem where you are exemplifying this or whatever,
Right.
So we did that, and that went pretty well.
So when they were doing that review, you were primarily doing review work on the board, and then they did some practice problems to get ready for this lesson.
And they would do homework.
Okay.
They did homework on it and things like that, and then also just doing Rocket Math, the fluency, to make sure that they're just their basic multiplication facts, single digit by single digit.
So where are they in Rocket Math? Because I was just in junior high the other day. I think you're on F.
Yeah, so I started in fourth grade with addition and subtraction, and because that's what we've been doing just in the textbook as well.
Right.
And they're pretty much all the way through addition and subtraction, which is awesome, because I'm about to start multiplication after Thanksgiving, so I can start multiplication in Rocket Math. And the fifth graders are, I think they're around year F. As well.
So that's probably helpful when getting them ready for this too. Okay,
So
awesome.
Rocket Math is important.
So when you were doing this lesson, because I see you brought a lot of fun things with them. So what was your ideal, your target? When you were planning this lesson, what was the end goal, or what were you hoping for them to accomplish?
The end goal was just to be able to do multi-digit multiplication. So be able to, if I give them any set of numbers here, 15 times 23, they just need to be able to, and not even in their head. I don't need them to do it in their head, but to be able to multiply this and to show their work.
Okay.
Which is important, because that shows me, or I can see exactly where they went wrong.
Right.
So most kids, when they do this problem, I did have one kid that just added, straight down.
Oh no.
I was like, what? Okay.
Yeah.
But then as soon as I was like, no, you have to multiply. He was like, oh.
Was it the X maybe that he was
maybe
that addition sign is lazy
he
today.
turned in his homework, and I graded it, and I was like, what was going on? So I was looking at his work and stuff, and when I gave it back to him, I was like, well, why did you add? He was like, oh, that is something I noticed. It was multiplication. Well, okay.
Well, it's good you realized it.
Yeah. Okay, so to solve this, you do 3 times 5, which is 15. So put the 5 there, carry the 1. 3 times 1 is 3, plus 1 is 4. Okay, and most kids can do that. They got that. But what they always forget to do is put a 0 here to hold their place before they move to the 2. So then you have to do 2 times 5 is 10, carry the 1, 2 times 1 is 2 plus 1 is 3, and then you add, so the answer is 345. Well, most kids, and especially in one of the math classes, the 5-1 class, the overwhelming majority, like, well, I've never had to do that before.
Like, what do you mean when they say?
Yeah, they're like, well, we didn't do that last year. We never put a 0 there. Which
do they leave a space?
That's
like
what I asked. I was like, so
did they
how
just
would
leave
you
that
do it?
spot empty?
They're like, no, you just put the 3 there and the 0 there. I'm like, well, that's not the right answer.
Right. So what was your strategy
so,
to kind of combat that issue?
So I found these fantastic, this great resource. Oh, not that. On where it has grids that have, these are 3 digits, because after we did 2 digit, we moved to 3 digit. But these grids that keep everything aligned for them, because that's another issue that they were having, is their handwriting is not always the best, and so they
get all crammed together.
Yeah, they don't keep numbers aligned, so they start multiplying just random numbers together that shouldn't be multiplied together. So I found the grids, which was great for keeping them aligned, and then it also has, so like on the very first one, just one, it has the 0 there for them to help remember. So I at first gave, and not all of them were struggling with it. So the ones who weren't struggling with it, I didn't give this to them because they didn't need it, and it wasn't. Most of them were like, "Well, I don't need, like, that doesn't make any sense to me." So
okay, so it's too many boxes and things they didn't understand.
Yeah, or they just were like, "Well, I always remember to put the 0," and they could like show me that they always remember to put the 0 by their homework and practicing in class, and so I didn't feel like they needed it. But for a lot of them, this putting the 0 here, and I started out by giving them this box on all of them, so there were 0s in all of them, and then gradually, as we practiced more and more, we moved to where there was only the 0 here, and so they had to remember to put it in all of when they did these problems.
Right.
Which took a lot of practice, but I think the other thing that they kind of, I think, helped a lot was when I was able to like model why we do that. So, okay, so for example, if I go back to this problem, 15 times 23, I was like, well, you can think of it, you can break this problem down, you can think of it as 15 times 3 plus 15 times 20. I'm like, okay, so we already did this, we already know what to do by when we have a 0 in the factor, so we can easily solve this, and you, most of them like already know that 15 times 2 is 30, and so then they were like, oh yeah, you just add another 0, and then I'm like, okay, if you don't know what 15 times 3 is, and 15 is a pretty easy one, so generally most of them would know, like, you can still multiply it out, and then you get 45, so it's 45 plus 300, and that got a lot of them like, oh, that makes sense.
So did you allow them to do it like this, like on their papers, if that made more sense than doing it that way?
Yeah, and for most of them, once they saw it this way, they're like, oh, okay, yeah, I definitely have to put a 0 there, and they were able to then do it this way. I think 10-year-olds are very question, like they want to know the reasons why for everything.
Why do I have to do this?
Yeah.
How's this going to benefit me
exactly.
later in life?
Yeah, exactly. So, so breaking it down so they could see, like, yeah, it's really, I'm really multiplying 15 by 3 and by 20, because this 2 here represents the number 20, which is something that we had talked about a lot in the first chapter with place value, because a lot of them would say, well, no, this number's 2. Well, no, the number's actually 20. So that once they were able to kind of make a connection between place value and what that means for multiplication, it helped a lot.
Well, that seems like a really great way to reach those learners who maybe didn't get it. Did you have some kids in the lesson that were like understanding like right off the bat? And what did you kind of do for those guys?
So since our 5th grade math classes are differentiated.
Right.
With the 5-2 class is the higher class, and like they never needed to do this. They never needed. I mean, I did show them this just so they could understand in their minds like why they're doing it.
Right.
They were like, well, yeah, okay. But
right. And then they were like, how many problems are we doing?
Yeah, exactly. Yeah. They were like, can you give us harder ones?
Yes.
Like,
well, that's good.
Yeah, I mean, because the specific lesson that we were doing only went like 3 digit by 3 digit. They were like, give us 20 digit by 20 digit. I'm like, hey, you don't have the room on your paper to do that.
They probably could do it.
Oh, they could.
Some of those guys.
They love on like as they're lining up, they love to just put like the longest division problem that they can like possibly come up with and just do it. I think there's like 3 on my board right now. They just like 18 digits and then just divide it by 3. They just do it.
That's
like,
awesome.
Is this right? I'm like, well, I have to do math.
You're like, hold on, let me get the calculator.
Yeah, yes. So that was good. There still were like a couple of them that were struggling, but really with them, a lot of it was just kind of modeling it for them on the board, saying like, oh, or just reminding like, hey, what did you forget to do right there? And I look at it and they're like, oh, put the zero. And they can easily like catch themselves. Whereas like a lot of the kids in 5-1, they're like, well, did I multiply wrong? Like, they're like, oh, well, maybe 3 times 5 isn't 15. That's where they think they go wrong. Right. If I ask them like, hey, what did you forget, or why isn't that correct?
Right.
Because I don't like to just tell them like, no, you're wrong. Like,
right.
Okay, let's figure out why you're wrong. Like, what did you do wrong, and like, how are you going next time? What are you going to do?
Right. And that's the best way to do it, and that's great because they're not going to learn it if you just say wrong, 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 and don't tell them. So that's awesome. Yeah. So what about this stuff you brought? Because I know you were talking, you wanted to give more ways for them to see this.
Yes. Yeah. So kids like Legos.
Yes.
Okay. So if, for example, we'll just go back to the trusty old 15 times 23. So if I have 15, 1, 2, 3, 4, 5. So there's the number 15 represented in manipulatives. And here's 23. 1, 2, 3. What I would do here is say, okay, so we'll take the 20 away, multiply, or model for me, how many more 5s do you need if we're adding 3 more groups of 5s? So then, I mean, they can just get out, and they're pretty much able to do this. Like, okay, well, I need 3 more groups of 5. 1, 2, 3, 4, 5. Okay. And then 1, 2, 3, 4, 5. Okay, and then if we have 1 there, and we need 3. 1, 2, 3. Okay, well, what number is that? 10, 20, 30, 40, 45.
Right.
Okay, cool. Now, let's set that aside. We need to keep our 45. Regroup at 15. I probably should say regroup, that's a math term. Go back to the original 15 that we had,
right,
and then multiply that by 20. So if I need 5 groups of 20. Or no, 20 groups of 5.
Right.
20 groups of 5, yeah. So then they would put out 20 groups of 5. It's going to take a while, so maybe I won't do it.
Right, yeah, no, I understand.
And then, okay, you need 20 groups of 1. How many is that? So then they get out 20. And then they say, okay, you have 45 here. How many do you have here? They would count to 300. And I'm like, okay, so if this was the 15 times 3 and this is the 15 times 20, how many total in all do you have?
So do you think the lower kids who don't understand the paper or the blocks, that this is a strategy that would be helpful, or do you think this is?
Some of them, it really kind of depends on what kind of learner that they are, and they actually took a quiz with Mrs. Hansen about like what style learner are you?
Oh, that's cool.
Yeah, which is awesome, but now they kind of like tie themselves to that. They're like, well, I'm a kinesthetic learner. I'm like, well, you can learn other ways too.
That might be your preferred method.
Right.
However,
so it's kind of fun. So I think when I was doing this, I was like, hey, like if you think that this is going to help you, if you need to like model it out, like here it is, model a problem for me. I didn't even give them a problem to do. I just said, model a problem for me and tell me what problem you're modeling. Like, show me that you can do it. And they could model it, and they could. Then I said, okay, now go put it on paper, and they could. Yeah. So for some kids, just being able to see and count out exactly how many they have was helpful.
So with the ones that didn't get it, the lower group that didn't understand exactly what they were doing, and you were reteaching, was this a strategy that you used?
Yes.
And it seemed to make it click for them a little bit better?
Yeah, for some of them. And some of them didn't need that, or they were like, well, yeah, I can just visualize that in my mind. Right. But some of them can't, especially, I mean, some 10-year-olds are very abstract or very concrete in their thinking.
Right.
So being able to count out exactly what they were doing was very helpful.
So you think, now that you've done it the one time and you were looking at some of the work that you got back that was really great, some that wasn't so great, what would you do differently? Like, if you could, like, rewind time and teach the lesson again, like, what would you change to make it?
I think that I would not just assume that they did in fact do it last year. I mean, I wasn't their teacher last year, so I don't exactly know, but I kind of just went into the lesson like, oh, well, this is in the 4th grade curriculum. I'm guessing they did it last year, so this is more a review kind of thing. But I mean, the like blank looks on like their faces when I was kind of, you know, like doing a problem on the board, it kind of like just threw me off for a little bit, and I had to like quickly try and like think of a way, because you know, I can do problems on the board all day long, but if they're not getting it, and I think a lot of times in math, as soon as a kid like sees a problem, they're like, well, I don't know how to do that. They just like check out. Right. And they're like, well, I'm just gonna sit here for the rest of the class. I can't do it.
Right.
So I wish that I had like thought of these kinds of things, like had them like prepared before I like went into the lesson.
Right.
I mean, like we did it the next day and the next day.
Right.
But I wish that because I think it kind of scared some of them.
Yeah, like they can't do it kind of mentality, which they can, but
right.
So from here you're going.
So now we've moved to division, which oddly enough they're fantastic at.
Really?
Not odd, but I kind of figured that, and maybe it's because we did so much work with multiplication that it just is able to click a lot faster. But I kind of figured that division was going to be more of a struggle because division like relies so heavily on knowing like multiplication facts, and it involves subtraction. But yeah, no, they're like on top of it, which is
so. Did you take some of this idea and do that when you were introducing this lessons to kind of that helped?
Yeah, we did some work with manipulatives. They still struggle with keeping things aligned, so using a lot of graph paper.
Is there anything magical for division, like where they have it drawn like that and they have the spaces?
Yeah, I haven't found one yet, but I was probably gonna make one over Thanksgiving break, because for those kids that have rough handwriting,
right?
I mean that's where their mistakes come from. They can do the math perfectly, but they can't keep anything else straight on their paper, so they bring down things in the incorrect place,
right?
Or they subtract incorrectly because they think that the 5 goes with the 3 when really the 5 goes with the 7,
right? So have you thought, and I know you said some of the kids are just like, they're on it, they get it. So you said you differentiate in your class. So what do you give those kids harder problems, or do you have them kind of move forward with?
Yeah, so we actually, in the 5-2 class, I was kind of trying to like keep them on pace with 5-1, but it just wasn't worth it. I was like, well, I'm going to end up doing like a disservice to these kids because, so yeah, we've gone on. I think we're like 4 lessons ahead right now, which is what it is.
Yeah.
And I've been able to kind of like explain to the kids like, well, they're just moving a little bit faster than you, so that you're going to have different homework assignments. So don't rely on your friends to tell you your homework. That happened a couple times. Yeah. But 5-1 with division is they do move at like a little slower pace. But like ability-wise, they're keeping up, which is really great. So we're actually doing the same escape room in class today. So I'm like, yeah.
So how do they get out when they have to solve problems? Is that the plan?
Yeah. So, and this one is Thanksgiving themed, so they have to save the turkey from becoming Thanksgiving dinner.
So is it a group? Like the whole class is going to work together, or are they in smaller rooms?
Yeah, they're in smaller teams. So they're working in teams of either 4 or 5, depending on the class size. Yeah, so they have to. I think this one is like 15 different puzzles that they have to solve, and it's all involving division.
That's awesome.
Yeah,
they're gonna have a lot of fun with that.
I'm excited. Yeah, I'm excited. And this one, we did one in science last week that was digital, so it was like on the computer. And I just put it on my projector and we did it together. But this one is actually not digital, so they get to like open the envelopes, find the right envelope to open. And
that's gonna be a lot of fun. They're gonna enjoy that. So. Well, that's good, and because it seems like you've got your head wrapped around the fact that you've got those kids that will not get it, you got those that do, and then you got the ones in between, and it seems like you've got strategies in place to make that happen. So good. Keep up the good work.
Thank you.
Yeah. Good job. You shut the box.
Sure. I don't know how long that was.
It's perfect timing.